We're going to work on an ALEKS problem that deals with calculating the pH of a strong acid solution. In this example, a chemist dissolves 491 milligrams of pure hydrochloric acid in enough water to make up 190 milliliters of solution. Calculate the pH of the solution and be sure that our final answer has the correct number of significant figures. We have to list all of our given information, and part of this given information is going to be a balanced chemical equation. So hydrochloric acid dissolves in water to yield Cl- and H3O+. We have to make sure the equation is balanced, and it is. I want to continue with my given information. I have mass of HCl. I have the volume of the solution, which is given in milliliters, but I want to convert this to liters. And I'm asked about the pH. Remember, the pH is the negative log of the concentration of H3O+. So I need to somehow get to concentration before I plug into my pH formula. So I have the mass of HCl, and I'm going to convert that to moles of H3O+. 1 milligram of HCl is 10 to the negative 3 grams of HCl. Grams in the denominator. I can get grams of HCl from the periodic table. This equals to 1 mole of HCl. Take a look at the balanced equation. For every 1 mole of HCl, I have 1 mole of H3O+. I don't want to round too early. I want to make sure my final answer is rounded to the correct number of significant figures. So I'm going to carry this out to more digits than I need. Now that I have moles, I can figure out the molarity of H3O+. Remember, molarity is moles over liters. Now that I have the concentration of H3O+, I can go ahead and use my pH formula. pH is the negative log of the concentration of H3O+. And my final answer needs to be in the correct significant figures. So significant figures for pH really is all about decimal places. So the concentration's significant figures will dictate the decimal places of the pH. So take a look at my given information. The concentration of H3O+ should have been to 3 significant figures. So 3 significant figures in concentration means 3 decimal places in pH. So my final pH is 1.149. Let's take a look at another example. In this example, a chemist dissolves 678 milligrams of pure perchloric acid in enough water to make up 130 milliliters of solution. Calculate the pH of the solution and be sure that our final answer has the correct number of significant figures. So part of this given information is going to be a balanced equation. HCl4 plus water will yield ClO4 minus plus H3O plus. Make sure the equation is balanced, and it is, so we continue with our given. We have the mass of HClO4, 678 milligrams. We have the volume of our solution, which is given to us in milliliters. I'm going to go ahead and convert that to liters. And we're asked about the pH. Remember, pH is the negative log of the concentration of H3O+. So I'm going to have to convert my HClO4 to moles of H3O plus. I can get the grams from the periodic table. And this equals to 1 mole of HClO4. Take a look at the balanced chemical equation. For every 1 mole of H3O plus, I have 1 mole of HClO4. Again, you don't want to round too early, so I'm going to take this out to a few more digits than I really need. I have moles of H3O plus. Now I need to find the concentration of H3O plus. Concentration is molarity, which is moles over liters. So the molarity of H3O plus is 0.05192. Now that I have my concentration, I can go ahead and plug into my pH formula. All right, so the significant figures in concentration will tell me how many decimal places in my pH. Take a look at my given information. The concentration of H3O plus should have been in 3 significant figures. 3 significant figures means 3 decimal places in pH. So my final answer is 1.285. Good luck and keep practicing.